Okay, welcome to day two. We are going to do some more complicated ciphering today. Those on the list right here. Now they're going to still going to use some modular arithmetic, but now we're going to mix in some matrices and some other kind of fancy stuff. And all these ciphers, I think the most interesting thing is about how the process of ciphering is undone by some kind of inverse process and why that actually works. It can be kind of interesting and kind of new to us and use a lot of number theory and things we haven't seen before. Today we're going to use the same book we were using last time. We're going to continue, but we're also going to dip into this other book for the first time for this semester I call it the TCMS book. We'll talk about that when we get there. Okay, permutation cipher. You've heard about permutations before. You heard about permutations probably in pre-calc or some other probability kind of setting before where you're talking about permutations, which is reordering things. So different arrangements of letters. So that's not a great name for what this is because it's a little more specific than that. But yes, it's about reordering. Okay, so we take out all the spaces in a message, and then you divide that string of letters up into some little sets of strings. So sometimes that's like 2 letters, sometimes it's 3 letters. It's 4 or 5 letters. It's pretty small. The one in the book I think uses 3 letters, so I think the example I have is for 4 letters. Okay, then we take a 2 by n matrix. They call that lowercase alpha in this book, which is a little strange, but that's what they call it. And then it just really, that's a pretty simple, you'll see a simple just kind of like, well, the first letter is going to move to the third letter and the second letter is going to move to the first letter, and just kind of how to scramble each one of those little substrings. So divide the message up into these little, same length strings, and then which is the same size as this matrix, and then just reorder them using that little reordering algorithm in that string. It's really pretty easy. If the original message does not divide evenly into strings the way then, so say you had you were supposed to divide it into little strings of 3, and you don't have a multiple of 3 number of letters, then add some nonsense letters at the end. And there's a lot of ciphers we've seen already, and there's going to be a lot more that do that. So, and then the decryption is really easy. You just have to figure out how to untangle each string so that it comes out kind of the opposite of the way you tangled it in the first place. Okay, so I made one up here. We're going to use letter strings of length 4, and all this really is just saying is that the first letter in the string is going to move to the third position after I chunk it up into groups of 4. In each group of 4, the first letter will become now the third letter in that chunk, the second letter becomes the first letter, etc., etc. So it's not like we're really multiplying by this matrix. This matrix is just a little kind of device reminder kind of key to show you how to reorder the spaces. Okay, so I am going to retype this welcome to the jungle message with kind of spaces put into different places. So it's going to look like this. At the beginning of that, it's going to be, notice that they have to be in strings of length 4. So we're going to go WELC, that's the first string, and then OMET, and then the next string OTHE, and then JUNJ, and then or G, and then LE, and just nonsense letters at the end. So that's fine. And then we do the permutation. So in that first string of 4 letters, the first letter, the way this works is that first letter goes to the third position, so the third letter is going to be W. The second letter is going to go to the first position, so the first letter is going to be E. The third letter goes to fourth, and the fourth goes to second. So the fourth letter is going to be second. The third letter comes from the first one, and the last one would be the L. And then in OMET, that's going to turn out to be EO, I believe. No, EM. And then the next letter was the fourth one, and the last one the first letter goes, let's do this again. The first letter goes to the third position. The second letter goes first. The third letter goes fourth, and the fourth letter goes second. It was the first letter that went third. So it's harder to type than it is to write. If you write these, it's easier. So why don't I pause and do it for myself? There you go. You didn't want to watch me struggle through that. It's kind of hard. Again, it's harder to type. If you're going to write these down, it's easier to just go, oh yeah, the first letter goes third, and I would just write that one down. And then the second letter goes first, and I would just write that one there. And the third letter goes fourth, and the fourth letter goes second, and just write them as we go. I'll do that as I do this one. It's actually a little easier to talk about. Okay, so what's going to happen here to find the descrambling matrix? And just think about how this would turn back into this one. Now, Now we have to think about these as the 1, 2, 3, 4 in in this position now. So this first letter, it needs to end up being the second letter over here. And the second letter in this string needs to be the fourth letter when we untangle. The third letter needs to move to position 1. And guess what? 4 needs to move to 3. Does this look familiar at all? Well, kind of, right? It's 2, 4, 1, 3. It's this backwards down here because it has to be under 1, 2, 3, 4 the other way. Anyway, if I was going to do that now, if I look at this thing and try to rescramble it, the first letter goes second, so I'll actually write it kind of over there. And the second letter goes fourth, so I'll put the C over here. The third letter goes first, so it goes there. And the fourth letter goes second. So it's easy. If you can write them out of order, that's a lot easier than typing. So I'm sorry. I'll do that one more time. The first letter goes second, so it's in that kind of space. The second letter goes fourth. The third letter goes first, and the fourth letter goes second. And as you can see, this is starting to turn right back into that. So once it does, we'll see this again, and then, bam, there it is. And then I'm just thinking, once you see, if you're the receiver and you know that this was the message you received and you were told to, you were given this as the unscrambler, or even if you were given this, you could figure this out. Anyway, if you were given this and this is what you unscrambled, hopefully anybody who understands English could look at this letter, look at these letters, put these back in without spaces and kind of go, okay, where does it make sense to put those spaces in so that this thing is intelligible? And that's just as far as that one goes. Okay, next one's Playfair cipher. This one is about a matrix of letters. I don't know if matrix is the best word because we're not really operating with it. It's just kind of a chart of letters that's in a 5x5 pattern. And then we kind of dance around in that chart to figure out how the letters scrambled up. So there's 25 spots in this matrix of letters. So it doesn't quite fit. So the standard way this works is you just don't use a Q when you use this cipher. Q is eliminated from the matrix of letters because it rarely occurs in English, so you just eliminate from plain text, hoping, just kind of like this last one, that if you receive something that has to be scrambled or kind of unscrambled by someone who understands English, they'll know that there's a Q there. Especially if they know it's a Playfair cipher, they know that Qs don't transmit, so they'll always be kind of on the lookout for where there might be a Q. All right, so this one is based on a keyword, and I highlighted this here because a lot of the following ciphers today and beyond use what's called a keyword to set off to create the cipher algorithm kind of in the first place for this particular the particular example you want to use. And so we insert that into the start of the 5x5 matrix. This cipher is really hard to explain by rules. It's a lot easier to just show by example. If it has any repeated letters, you have to take it out. You'll see why. Divide the plain text message into strings of length 2. So it's always 2 on this one. It's not variable. You have to divide it up. We divided the last welcome to the jungle into bits of 4. This one will have to be bits of 2. And then this is kind of strange. If that ever forces you to make a repeated letter in that little 2-letter string, you can't do that. It won't work. So you put a filler X as the second letter in that string and then go on from there and just kind of put that X as a filler and then move on from there. Okay, and then that's another one where the reader has to figure it out. If there turns out to be an odd number at the end, you put an X at the end, unless that would be a double X, which rarely happens, and then that last letter becomes a Z. And I said here again, that's really hard to figure out. Then once you get that all figured out, there's this really complicated way to, again, dance around that matrix to figure out how that thing scrambles up and how it changes into the encoded message. If they're both in the same row, you just kind of scoot them down to the right, and then it circles back to the front of the row if it's at the end. If it's in the same column, you scoot them down the column, and then, of course, if it's at the bottom, you loop it around to the top. But most of the time, they're going to be in different rows and different columns. If that happens, if you have something like here in the matrix and here in the matrix of the 2 letters in the bit, then you look at the other diagonals of that rectangle, and they turn into those. Each letter is then replaced by the letter in the corner of the same row. So this letter would become this one in the encrypted message, and this letter would become this one. Okay, again, it's way easier just to do this by letters. Okay, so I'm making up I had my son help me with coming up with some letters that might work. So first of all, I'm going to take Jigglypuff and put it into the two-letter thing. I picked some repeat letters on purpose here. So I can't have GG. I have to insert an X there. So when you have 2 G's in a row, or 2 G's that would end up in the same pair, that can't happen. So you have to split it up like this. Now I can keep going. L, Y, P, U, F, F. This FF doesn't need to have an X in between it because it's in two different strings anyway. Because basically each one of these pairs has to be two different letters. And you can never have the same letter twice in a pair because if you think about the rules, that just doesn't make sense. Okay, create the ciphers matrix. Okay, so Mario Kart was the keyword we're going to use. And this is a 5 by 5. So I say M, A, R. Oh, yesterday was March 10th. That's cool. Mario K. Remember, I can't have two letters. I can't have the A repeat, so I skip this in the keyword. Oh, and I skipped the R. I can't have an R either. I've already used an R. Because remember, I've got 25 spaces in here, and that's for all the letters except Q, so I can't take up extra spaces there. So this is the keyword. And all that basically means is this is how much we're going to scramble up this alphabet kind of. So all those letters have been used. Now I use the rest of the alphabet in order until I get to here. I put X, Y, Z there because I wanted to make this matrix print out the right size. Anyway, let me fill out the rest of this. So A, B, C, D. I can use E. I'm just using all the letters I haven't used yet. So that's all fine until I get to, like, I guess I, right? H, I can't use I because it's already been used. J, can't use K, it's already been used. H, J, K, L, M, N, O, P. L, M, been used. N, O's been used. This is kind of hard. O, P, there's no Q. R, been used. S, T, been used. U, and you know you did this right if this happens and it works out. So good for me, I got to work. So here's that 5 by 5 matrix where we are going to apply all of these rules. Okay, so let's do that. Okay, so I re-typed this matrix thing so you can see it a little bit better. Let's put the plain text strings back in there. All right, now let's see how those things translate into this process. So J and I are at two different kind of parts of a rectangle here. So the other corners of that rectangle would be O and H. So the J turns into H because it's in the same row. The J turns into H and the I turns into O. Okay. Next, G and X. So G, oh good, there are some different things that happen here. G and X, those are in the same column. So what happens is they move down. So G is going to move to the next letter below that, which is P, and X is going to move to the next letter below that, which is a loop around, and we get R. Okay, then next we have G and L. Notice G and L here. There's the G and there's the L, so that's the rectangle way. G and L, the other things in that rectangle are E and P. G moves to E, L moves to P. All right, then next we have Y and P. Y and P are kind of, I'm not going to draw these every time. Y and P are another rectangle. P moves to S. Sorry, P moves, ooh, I got that wrong. P turns into S, which is over here, and Y turns into X. Did I do the rest of these right? I'll check that later. U and F, big rectangle. U and F turn into N and J, where U turns into N and F turns into J. And then we have F and X, another rectangle. F and X turn into G and W. Okay, now what never happened here, we never ended up with two things in the same row. So if I had like a K and a B at the same time, the K and the B would turn into T and C. Everything moves one to the right. Okay. I realized I made one mistake already. This should not be F, of course. The U and the F were right here, U and F. U turns into N, but F turns into J. There we go. And then in F and X, F goes to G, W goes, X goes to W. Right. So notice this F turns into J, this F turns into G, right? It has everything to do with what the other letter is in that pair. This G turned into P, this G turned into E. So how on earth are we going to untangle this mess? Okay, so it says to decrypt a Playfair cipher, we need to reverse what we do in step 3, rules above, for the same column in the same row. We basically just need to go immediately left or down, and yeah, it's actually a little bit simpler than you might. So think about this. If you had the H and the O, look where the H and the O are. The H and the O are part of a rectangle where the other corners are I and J. H would go to J, O would go to I. The G and the X, that was one where it was the same column. G and X turned into PR. So we'd have PR looking at P and R. Instead of, because we're doing the backwards version, we can't go down to go into the same column. We'd have to go up. So the P would turn into G and the R would loop around and turn to X. The rest of these were all rectangles, so you would know what to do. All right, I'm about out of time. I'll see you in part 2.